Good morning one and all. So let us start second unit. So please read the first unit carefully. I'll give assignments later from the first unit. So without much delay, let us start the unit 2. Now here in unit 2, basically we discuss some of the important concepts like random variables. So before that, so let us discuss independent and repeated trials. Okay, you take a simple example of tossing a coin multiple number of times. Suppose you are tossing a coin n times, n toss of a coin, n tosses of a coin. So here those tosses are considered to be independent of each other, which means so the outcome of a toss is independent of other tosses. Suppose you are tossing 10 times, each time the outcome is independent of other tosses and they are identical. Obviously you are tossing the same coin 10 times, so you are repeating the experiment, which means all these stages are identical, which means you're tossing first time, second time, third time, fourth time, all are identical. You're tossing the same coin, but each time you toss a coin, the outcome is independent of previous tosses. Here, one more thing is the special case is there are only two possible outcomes. In the tossing a coin experiment, the possible outcomes are already head and tail. So then those kind of trials are called Bernoulli trials. What is Bernoulli trial? Independent, identical, and which has got only two outcomes are called Bernoulli trials. Example, tossing a coin or conducting an experiment multiple number of times. Suppose you are conducting an experiment 10 times. So obviously they are independent and you are conducting the same experiment, they are identical. At the same time, if you do an experiment, the results could be either success or failure. So they are also modeled as a Bernoulli trials. Okay. Now, so what is next? Obviously, head and tail of a tossing a coin experiment. So I have taken a simple example here. So what example I have taken here is, so we are tossing a coin 3 times. 3 tosses of a coin. 3 tosses of a biased coin. 3 tosses of a biased coin. So already biased means what will happen? What will happen? So if it is a fair coin, generally what we get? So fair coin means what? The probability of head is same as probability of tail is equal to 1 by 2. That is a concept of fair coin. But biased coin means what? They don't have same probabilities. So in biased coin, what we do? So the probability of head, we say that P. Let me take one more. If it is a biased coin, what we assume is the probability of head is P. Probability of tail is obviously 1 minus P. That is also called as Q. Okay, now we are tossing 3 times. So the possible outcomes are 2 power 3, that is 8. So the sample space will have 8 outcomes. What are they? All heads, head, head, tail, tail, head, head, so on, so on, so on. Finally, tail, tail, tail. So the sample space has got 8 outcomes. These are the possible 8 outcomes. Okay. Now here, so here I have written the corresponding probabilities also. What is the probability of getting 3 heads? PQ. Getting head, head, tail. Head means P, tail means P, head means P, again head means tail means 1 minus P. It becomes P square into Q. Otherwise p square into 1 minus p. Correct? So what the probability of head, tail, head? It is also same. Head, tail, tail, p into 1 minus p whole square. Otherwise, you can also write this as p into q square. Tail, head, head, this is a probability. So in this diagram, we have all 8 possible outcomes and along with their corresponding probabilities. Here, instead of 1 minus p, you can write q, which means you can write q cube. You can write here, you can write this as p into q square, so and so. Okay. Suppose if I ask you a question, in the same experiment, if I ask you a question, the question is, so what is the probability of getting one head? Probability of getting one head. What is the probability of getting one head? What will you do? So here, how many such possibilities are there? One head. There should be only one head. This is the one possibility. Head, tail, tail. There is only one head. Here also one possibility. Tail, head, tail. Here also another possibility. Tail, tail, head. So these are 3 possibilities for the corresponding event. What is the event? Getting one head. And what are the corresponding probabilities? Head, tail, tail, pq square. Here also pq square. Here also pq square. So all are having same probability, that is p into q square or p into 1 minus p whole square. Now what happens to this probability now? There are 3 possibilities, that is first probability p into q square, second also p into q square, third also p into q square. Total 3 into p into q square. Suppose if I change the question, I ask you 2 heads. What is the probability of getting 2 heads? Let me go back to the diagram. Here, how many such possibilities are there? 2 heads. 2 heads means this one, this one, this one. What are their probabilities? P square into q. Here also p square into q. Here also p square into q. So all are having equal probability, that is p square into q. How many are there? 3. So obviously p square into q, plus p square into q plus p square into q. Total it is also 3 into p square into q. Correct? 3 heads. What is the probability of getting 3 heads? How many such possibilities are there? 3 heads means simply you are tossing 3 times. Each time you get head. How many such possibilities are there? Only one. What is that? 3 heads. Head, head, head. What is the probability? P cube. No need to mention any other things. Suppose if I ask you what is the probability of 0 heads, which means no heads. Probability of 0 heads. So which means there are no heads, which means all are tails, which is also same as 3 tails. Which means you got all 3 tails. What is the probability? 1 minus p whole cube. It is also same as q cube. So these are all the probabilities. Now, so let me take the generalized formula. So here in the previous examples I have taken 3 tosses. Okay. In general, n tosses. What is P of k? Probability that k heads come up in a n toss sequence. Okay, what is that probability? What is the probability? This is the probability. This is very, very important. This formula is very, very important. So the probability of getting k number of heads is called P of k, that is nk into P of k 1 minus P of n minus k. See, this is what is called n choose k or nck. Nk we read generally like this, but this meaning is nck, n choose k combinations. What is the formula of nck? n factorial by n minus k factorial into k factorial. Okay, now the formula is generally, so if you take any generalized experiment of tossing a coin n times, then what is the probability of getting k number of heads? P of k equal to nck p power k q power n minus k. You can also write q power n minus k. Why? Because what is q equal to? 1 minus p. See, if you remember, we have done same thing in the previous example also. Yeah, suppose in this example you are tossing 3 times, which means n equal to 3. N equal to 3. Probability of head is p. Probability of tail is 1 minus p or q. I am writing q. What I am asking you, the first question, what I asked you to do, getting 1 head, which means here, what is the value of k? Here k equal to 1, n equal to 3. Correct? N equal to 3, k equal to 1. Which means they are asking p of 1. What is that? N equal to 3, that is fixed. 3c1 p power 1 q power 3 minus 1. What would be the answer? The answer would be 3c1 p into q square. What is 3c1? 3 factorial by 2 factorial into 1 factorial. That is how much? Again 3. 3 into p into q square. So the probability of getting 1 head is 3 into p into q square. Same thing you got. In the same way, getting 2 heads means what would happen here? So n equal to 3, n equal to 3, k equal to 2, which means 3c2 p square q. That means 3 into p square into q. Suppose getting 3 heads, which means n equal to 3, k equal to 3. What happens now? P of 3 equal to 3c3 into p power 3 q power 3 minus 3. That equal to 3c3 into p cube. That's it. What is 3c3? Again 1. That is simply p cube. Suppose if I ask you getting 0 heads. Getting 0 heads. Getting 0 heads, which means n equal to 3 and k equal to 0. What is the probability of getting 0 heads? That is 3c0 p power 0 q power 3 minus 0. That equal to 3c0 q power 3. That equal to q power 3. This also equal to 1 minus p whole cube. Okay, in this way you can find out any possibilities. Yeah, so this is NCK called binomial coefficient. What it is called? Binomial coefficient. Next. P of k is called binomial probabilities. What are they called? Binomial probabilities. Okay. So please remember these terms. We'll discuss later few more problems. You know what is the formula of NCK? I have written here. What is the formula of MCK? You know already, no need to write again and again. N factorial by n minus k factorial into k factorial. But k varies from 0 to n. 0, 1, 2 up to n. Okay. Now, so without wasting much time, so let us move further. So it is not important to us. I told you already these things anyway. So we'll solve some typical problems of probability. You might have solved these problems in your previous courses, maybe in PUC courses, but so let us solve simple problem. Okay, it is simple probability. So a telephone number is a 7-digit sequence but the first digit has to be a different from 0 and 1. How many distinct telephone numbers are there? That's the question. Read the question properly. A telephone number is a 7-digit sequence, but the first digit has to be except 0 or 1. Okay. We proceed further. So they are asking about the possible distinct telephone numbers. It has got 7 numbers. Total 7. You know already in a telephone number, each digit can be starting from 0 up to 9. 0 to 9. How many digits are there now? 0 to 9. How many numbers are there? 10. 0, 1, 2, 3, 4, so on, so 9. Now the condition given is, here the first digit, it should not be 0 or 1. Okay. It cannot be 0 and 1, but it can be anything between 2 to 9. 2 to 9. 2 to 9 means how many such numbers are there? 8. So for the first digits, there are only 8 possibilities. For second digit, 10. Second digit, we don't have any restriction. You can use all 10 digits, 10 numbers. Third digit, third place, first place, 8 possibilities. Second place, 10. Third place, 10. Fourth place, 10. Fifth also 10. Sixth also 10. 7 also 10. Okay. Now, how many such distinct numbers are possible? 8 into 10 power. How many are there? 1, 2, 3, 4, 5, 6, 10 power 6. So, these many distinct telephone numbers are possible by given condition. Okay. Yeah. Now, so we focus on permutations and combinations. You might have known all these things already, but let me briefly tell you what is a permutation and what is a combination. Suppose you have a collection of some objects. You have a collection of how many objects? N objects. From n objects, you have to select k number of objects. Obviously, n will be always greater than or equal to k. So from the collection of n objects, you have to select k number of objects. You can do so by 2 methods. Okay. One is selection without order or selection with order. Selection without order, selection with order. If the order of the selection is matters, it is called as a permutation. If the order of the selection doesn't matter, it is called combination. Which means, so in the process of selection, if you give importance to the order of the selection, it is called permutation. If you don't give any importance to the order of the selection, it is called combination. Okay. So these are two different ways of selecting k number of object from the collection of n number of object. Okay. Yeah. So here this is very, very important. So permutations, in the permutations there is a order of the selection. In the combination there is no order of the selection. Now, so let me take a simple example. Two permutations of letter A, B, C, D. They are asking A, B, C, D's are 4 letters and you have to select 2 letters among 4 letters. Now, how many different ways you can do so? So let me write all 4 letters. They are A, comma, B, comma, C, comma, D. Now select 2 letters. Okay, first of all, let me select A first and B second. I want to give importance to the order. Here, what I have done? First, I have selected A, later I have selected B. I will do reverse. First, I will select B and later I will select A. Now, A, B and B, A, they contain same elements, same objects, but the order of selection was different. Now, here I am giving importance to the order, which means I am doing permutations. A, B, B, A possibilities are there. Next, in the same way, A, C, C, A. Next, A, D, D, A. Next, B, C, C, B. BD, DB. Next CD and DC. How many such possibilities are there? 12. How many? 12. You know already, always. Permutation means, generally what we say? NPK. Permutation means what do we write? NPK. Means n factorial by n minus k factorial. So here we have total number of objects are 4. From 4 we select 2. So 4p2. What is 4p2? 4 factorial by 2 factorial. That equal to 12. This is a permutation because we are giving importance to the order of selection. Suppose, let me take combinations. I don't bother about the order of selection. I just want to select 2 letters at a time. What will happen now? I have 4 letters A, B, C, D. I want to select just 2 letters at a time. I will select AB. I don't think about the order. It's over. I have selected 2 letters. It's over. Next, AC. Next, AD. The same way, BC and BD and CD. How many are there? 6. It is called combination. So combination means generally we write NCK. In our formula already I told you. Here 4 are there. We have to say from the letters, 4 letters, we have to take combination of 2 letters. 4C2. 4 factorial by 2 factorial into 2 factorial. That is equal to 6. So that is a difference between a permutation and a combination. So one more problem, tattoo. In how many different letter sequences can be obtained? How many different letter sequences can be obtained by rearranging the letters of the word tattoo? Okay, can you solve this problem? Here what we do here is, so let me take the word tattoo. First of all, how many letters are there? 1, 2, 3, 4, 5, 6. So in how many ways you can rearrange? Rearrange means again permutations. Arranging means permutations. How many ways? 6 factorial. Because we are rearranging all objects, all letters. 1, 2, 3, 4, 6 are there, 6 factorial. But some of them are repeating. You can observe clearly here. T is occurring 3 times. That's why 3 factorial. A is occurring only 1 time. That's why 1 factorial. In the same way, O is occurring 2 times. That's why 2 factorial. That is simply 6 factorial by 3 factorial into 2 factorial. Why? Because 1 factorial is nothing but 1 only. So the answer would be 60. So in the 60 different ways you can rearrange the letters of the word TATTO, tattoo. Now this is one more way of writing. I told you already binomial probabilities means NCK, P power K, Q power N minus K. Yeah, so here if in any order, suppose if you want to write in any order, this is NCK, P power K, Q power N minus K. I told you already NK is also same as NCK. Please remember, this is a notation. If in the specific order means P power K, Q power N minus K. Okay. So let us solve one problem. Yeah. Here, so a fair die is rolled 5 times. A fair die is rolled how many times? 5 times. Find the probability that 6 will occur twice. It is again repeated trials, which means a die is rolled 5 times means n equal to 5. Probability that, what is the event of occurring? 6. How many times you have to observe? 2 times. What is the probability that 6 occurs 2 times? we are rolling the die 5 times, fair die. Okay. Now everything given to us, it is a 6 face die. Okay. So what will you do? First of all, so 6 face die is given to you. N equal to 5, it is rolled 5 times. We have to observe how many, we have to observe that 6 occurs twice. We have to observe what event occurring 6. So what the probability of occurrence of 6? If you roll a die, so it is equiprobable. Occurrence of 1, 2, 3 all are same, which means occurrence of A is 1 over 6. That is nothing but P. Occurrence of A complement is nothing but 1 minus 1 by 6, that equal to 5 by 6, that equal to Q. So we have everything. We have N, K, P, Q. Okay. So what the probability that 6 occurs twice? So which means probability of getting 6 2 times. That is 5C2 P power 2 Q power 5 minus 2. That equal to 5C2 P square Q cube. What is 5C2? 5 factorial by 2 factorial into 3 factorial into, what is P? 1 by 2, sorry, 1 by 6 whole square into, what is Q? 5 by 6 whole cube. So that is the answer. Correct? Okay. Now, so that is about some basic concepts of probability. Now we will start something very, very important, that is called random variable. What is called? Random variable. So you try to understand the concept of random variable now itself, because it won't leave you until 4th year. You encounter random variable so many times in your BTech curriculum. Okay, that's why try to understand the things properly now itself. A random variable is a real valued function of an experimental outcome, which means, so let me explain with a brief figure. So if you conduct any experiment, you will get some results. So the combination of all such results is called a sample space. Is called a sample space. But so here, using random variable, what we do here is, x is a random variable. What we do is, we assign real numbers. What we do? We assign real numbers to, we have some elements in a sample space. What we do? We assign a real numbers to the elements of a sample space. To the elements of a sample space. This is called random variable. Assigning a real value numbers to the outcome of an experiment. Okay. I will take simple example. Now, so you take this example of a rolling a d4 die 2 times. I am rolling a d4 die 2 times. You know these things already. Okay. Now, so here I have defined random variable like this. A random variable is x. What is that? Maximum of 2 rolls. Okay. Suppose, so if you got this as a result, what is that? 2 comma 3. 2 comma 3, what is the maximum? 3. So this will be given a real number of 3. Correct? Suppose you take this 3 comma 4. What is the maximum of 3 comma 4? 4. Okay. You take this 1 comma 1. So what is the maximum 1 comma 1? 1. Now in this way, I have assigned real numbers to the all the outcomes of this experiment. Okay, so this is sample space lambda, sorry, omega. So I could able to assign real numbers to all the outcomes of an experiment through random variable. So by using random variable, we assign a real numbers to the outcome of an experiment. That's it. Okay. Now, so for example, in experiment of rolling a die, 6-face die, D6 die, the following are examples of random variable. What are they? Sum of two rolls is a random variable, x. Why? Suppose in the same experiment, if I take sum of two rolls, what would happen? 1, 1. Sum of 1, 1 is 2. You get 2 here. 2, 3. Sum of 2, 3 is 5. Sum of 3, 4 is 7. Okay, still this is also another random variable. What is x here? I have chosen x to be sum. Okay, so that is also another possible random variable. Next, number of sixes in the two rolls. Yes, it is also a random variable. Why? How it is possible? Suppose that is a 6-face die. Suppose I take only few elements in the sample space. I am taking only few. Actually, there are 36 number of elements in sample space, but I will take only very few sample spaces. Elements in the sample space. 1, 1, 2, 6, 6, 6. Let me take. So here, what is the random variable? That is number of sixes. Now, if you assign this, what will happen? 1, 1, how many sixes are there? No sixes. Means we get 0. 2, 6, how many sixes are there? Only 1. 6, 6, how many are there? 2. Okay, it is also a possible random variable because we could able to assign a real number to the outcome of an experiment. Yeah. So here one important thing is we are discussing a discrete random variable. Please remember, so random variable is two types. One is continuous random variable, one is discrete random variable. Continuous random variable CRV, discrete random variable DRV. Okay. Now we'll discuss discrete now. Later we'll discuss continuous. So when it is called discrete, a random variable is called discrete if its range is finite. What is the range? Set of values that it can take. Set of values that it can take. If the range of the random variable is finite, it is called discrete. Which means what is the range? Here. So what is the range of this x? X is a random variable. What is its range? 0 to 2. So range is finite. So that's why it's called discrete random variable. Okay. In the previous example, what is the range? Here what is the range? 1 to 4, 1, 2, 3, 4. So range is finite. Here what is the range? Up to 12, 2 to 12. So here also range is finite. The range of the random variable is finite. It is called discrete random variable. What is the range? The set of values it can take. Okay. So we'll discuss about PMF later. Okay, we'll stop here. Thank you.